rewrite sines and cosines. So if definitely you were stuck, that's the first thing you would do. What else could you try?
You pull out that?
I don't have any like terms. If I did, I could try that. But if you were stuck, what else works here? You could. Usually it's only when you have one term. Here I have addition going on. But yes, it's something you could try. Yes, but be careful. I mean, these are all yes. You could try all of these. Trying to lead you to the right one. You'd have to divide. If you did that, it would be this. Right? You'd take the whole denominator, divide each term. You can make substitution. What's another obvious one you're forgetting? Common denominator. Hello? Yes. Okay, I could try common denominator because I'm adding fractions, right? So you see, if this was a homework problem, you have so many things to try. So I won't accept only 1 or 2 lines. That's not a try to me. My definition of try is a whole lot higher than some of yours. Okay? But make substitution is the best one because you should have alarms going off. You see those squares and ones? Remember, I said anytime you see those squares and ones, you should be thinking Pythagorean identities. What do you see here? Is which one? Bottom. Now, a lot of people mistakenly say the top is negative secant squared, which is mucho wrong. Because no matter how hard I try, my identity is this. 1 plus tangent squared x equals secant squared x. No matter how hard I try to rearrange that, you will never get 1 minus tangent squared. So that's kind of a red herring right there. You see the 1, you see the square, but it doesn't get you anywhere. Now we're going to do what Cole suggested. How about we divide each term now? Makes it nicer that there's one thing down there. So this is 1 over secant squared minus tangent squared over secant squared plus 2 sine squared. Now I will tell you that some people go common denominator, which is going to get you right back to where you were, which will happen. We will go in circles sometimes. But now how about we try what Blair suggested? Let's go to sines and cosines now. Now it's a little nicer. Well, hey, what's 1 over secant squared? Cosine squared, right? This I have to do a little work. That is, tangent is sine squared over cosine squared all over 1 over cosine squared, right? Change my tangent, change my secant. This I'm going to leave because it's already in terms of sine. So I change my tangent, change my secant. What do you think I want to do next? Okay, I see. So this just comes on down. Don't ever drop part of the problem. Comes on down if you didn't use it. So I have keep, flip, and change to multiplication. Bring the rest on down. Don't just kind of work on one part. A lot of people want to do that. Work on one part of the problem and drop some of it. Now what do we notice? Cancel, cancel. So I'm left with cosine squared x minus sine squared x plus 2 sine squared x. Not quite, because they don't all have a sign. But aren't these like terms? Isn't that 1 sine squared, 2 sine squared? Combine those, I get positive 1 sine squared, right? Negative 1 plus 2. And what is that? 1. That's the unit circle. They're not all going to be this hard the first time, except I'm going to ease you into it. But the only way to learn these guys is to practice, practice, practice. Try. Okay? The only way to learn these is just try a strategy, see if you get stuck.
So for everyone, like every step we go just go straight down?
Yes.